All right, welcome to Unit 3, Day 4 Notes on Complex Fractions. The toughest thing to know about complex fractions is that there are so many different ways to do them. You could learn one way from one teacher, another way from a different teacher, and then find an entirely different way to do them online. The purpose of this video is to go through one of the methods, and then I'll create another video going through another method, which are commonly taught at the school I teach at. So the first thing to do with complex fractions, no matter what you're doing, no matter what method, is to create a fraction out of everybody. So if you have like a little floating guy, I like to say, you put him over 1. So I'm looking at like number 2 is what I'm going to go through with you guys. If I put that over 1, now everybody's a fraction. Now what I'm going to now do is change each fraction by adjusting the numerator and denominator. And once I have the same denominators, I can cancel each denominator and simplify. Okay, so I'm going to focus on doing just number 2 here. Okay, so with this process, you are simply looking at all of the denominators and deciding on a common one among all of them. So that would be 32. So I'm going to write this off to the side. So now I'm going to manipulate anybody who needs a common denominator of 32. So for example, this guy needs a 32, so I'm multiplying by 32. This guy needs a 2 to get to 32, and this guy needs a 16. Now let me rewrite this so that you see it more clearly. I have now x squared over 32 minus 64 over 32 all over 2x over 32 minus 16 over 32. Now, once you have all the denominators the same, you can actually drop them out. And I'll show why after the fact. And then you can set it equal to what you have left over in the numerator. So x squared minus 64 over 2x minus 16. That numerator factors using a difference of 2 squares. Bottom is a GCF. X minus 8's cancel, and that leaves you with x plus 8 over 2. Now, it's not magic why I'm canceling out those 32s. Let's actually explore why I'm able to do that. If you were to combine that numerator to a single fraction, that would be x squared minus 64 over your common denominator of 32 and 2x minus 16 all over your common denominator of 32. Now, as we know, if you're dividing fractions, you can change the expression by doing keep, change, flip. So I can keep the first fraction, change the sign to multiplication, and flip the second fraction. Now, based on keep, change, flip, I'm noticing that 32 divided by 32 reduces to a 1, and now I'm back at the same place I was at that step. So again, the reason I'm able to cancel all those 32s in the denominator is because really it's like I'm reducing a 1 over 32 in the numerator and denominator, or think about it as keep, change, flip. Those 32s would drop out anyway. All right, so using this method, I'm going to do one more. So like if I look at number 4, I would look at my denominators of x, x, and y and decide that a common denominator among all of them would be xy. So that means that he needs a y, keep in mind it's times binomial, he would need a y, he would need an x. So by doing this, I have all my denominators the same. So at this step, you can actually cross those out. Let me change my color. So in the numerator, I have y times x plus y all over y plus x. Those are opposites with addition, so they're going to reduce to 1, and we're left over with a final answer of y. Okay? And that is how you would do complex fractions. I think I can probably do one more. Let's do one more. Okay, so just going down the row here, number 6. Okay, so common denominator among all of those, I would say, is a 4x. So that means he needs a 4, he needs a 2x, he needs an x, and he needs a 4. Once I know I would have the common denominators the same, I have 2x squared minus 32 all over x minus 4. Now I can factor out a GCF, which reveals x squared minus 16, which, as we know, is dots. So I'm just going to factor that right above it. Okay, x minus 4's cancel, and that leaves me with 2 times x plus 4. And that is complex fractions when you get all common denominators in the numerator and the denominator.